Here we have a digital oddity, or diode for short, in its natural digital environment. Like all good digital pets, the diode starts out as a self-extracting egg archive. As is normative for this sort of creature, the diode will eventually grow into one of several adult forms based on individual genetic and environmental pressures. But even at this stage, all of its eventual forms are present in its code, needing only the correct stimulus to activate. Despite the great variety of forms the adult form can take, the same design themes can be seen throughout. A dinosaur-themed diode will never turn into a slug that then turns inexplicably into a teddy bear. When I was coding the diodes, I realized that I was going to be making a lot of these guys. I wanted them all to be at least slightly different, but I didn't want to have to make an entire scene for each one, so I didn't. Instead, I just wrote a single diode scene and harnessed the power of resources to make a custom diode resource that contained all the diode's unique info, as well as a reference to the built-in sprite frames resource that I'd passed to the animated sprite node. Rather than tell you exactly how I did it, I'll just link the video I used as a reference up in the card, and then you can give that guy some YouTube algorithm too. I did, though, figure out how to get it to update live in the editor like this. The key was to set the main script that read from the resource to be a tool, and then check if it changes. And the tricky part to watch out for here is that if the resource affects a child node like mine did for this animated sprite, you'll actually need to do the updates in two places. Once in the ready function, and once in the setter. If you only do it in the ready function, it won't update in the editor when you change it after it is already loaded. If you only do it in the setter, then it fires before the node is actually ready, and so the child node isn't actually conceived yet, and it crashes. When trying to concoct what a diode even is, one of the ideas that I liked was that they're not abstractions of a fanciful creature in a fantasy realm. They are literally programmed creatures that live in the digital dimension I've written up here, so that they are actually real in a way that, say, a Pokemon isn't. Just watching creatures do their own thing isn't much of a game though, so I added this little ghost. It is not a diode, but rather the digital manifestation of an incomprehensible extra-dimensional entity from beyond ones and zeros, i.e. you, the player. It can't do much on its own, but it can come over to a diode and boop. Now you are the diode. It wasn't too hard to code either. When the ghost interacts with a diode, it just saves a reference to the diode node and calls its functions instead of its own on user input. On the diode side, I have it either listen for commands from the AI node I made if it's on its own, otherwise it just sits there until the player ghost starts sending it stuff via user input. So when trying to figure out how I was going to do the race, my initial thought was to try and recreate Wacky Wheels. But I had my daughter try it out first, and she wasn't really into it. My next idea was to make one of those old running games where you had to mash left and right really fast. She liked that idea better, but that seemed boring to me, so I needed to add a twist. And that twist was ankles, by which I mean tripping. You need to alternate pressing left and right, but if you ever hit the same one twice in a row, the diode you're controlling hits the ground face first. But that's not the only way to eat it. In the spirit of nothing is just a sprite swap, I gave each one different acceleration per button press and different top speeds they could hit before they automatically tripped. To attempt to balance them out, essentially the faster a diode accelerated, the lower its top speed was. It creates this mechanic wherein you mash it first, but as you approach the diode's top speed, you need to slow down the mashing enough so that you stay just under the max tripping speed, but never pass it, which makes the optimal speed you hit the buttons a bit different depending on the diode. I gave them a little exclamation mark to indicate when you're approaching the max speed, so you have a visual indicator of approximately the optimal zone. And that's what I've gotten up to so far. I obviously need to add some visuals to the race. I need to do the sprites for the other 5 second stage diodes I have planned, and I need to get that swing back in there to complete the objectives my daughter initially set out for me. I think I'll have the initial version of this finished up by the next video. But first, There's a dare I need to deal with. A ludum dare.